In this video, we are going to talk about midpoint and how to solve it when I'm given a segment and how to prove it. We're also going to talk about what the difference between congruent, midpoint, and when to use the midpoint formula. So let's start with congruent first. So congruent is going to be this symbol right here, which is an equal sign with a little tilde on it. And it's going to state that the segment AB is congruent to segment BC, then, and this is an error, let's get rid of these lines here, then the value of AB is equal to the value of BC. So congruent means the same. It does not necessarily mean equal, it just means the same. Okay? So once again, the segment of AB is congruent to the segment of BC, then the value of AB is equal to the value of BC. Okay? That's going to be really important when we get into the proof. Now, looking at midpoint, a midpoint is the point that cuts a segment in half, and more importantly, in equal halves. Okay? In equal halves. If B is the midpoint of AC, then segment AB is going to be congruent to segment BC. And since they're congruent, that means the value of AB is equal to the value of BC, like we stated above. These are going to be really important when we get into the proof part of this lesson. The last important thing to point out is the midpoint formula. We use this when we're not given a picture and we only have coordinates or points on a graph. Okay? Our midpoint, since it's a point, is going to mean that using this formula, we should have answers that are in the form of x, y. Okay? So we should have answers in the form of x, comma, y. Now, let's dive into the proof now that we've finished vocab. So I'm going to give us the problem as such. We have a line segment here with endpoints A and C. There's a point B. And I'm going to tell you here that this is 18. And that's all I'm going to give you. Okay? And so that is your given. There's your problem that is given. Now, up here it says that we're trying to prove that segment AB is equal to 9, given B is the midpoint of AC. So now that we know that B is the midpoint of AC because it told us, we can also say in our proof that that is given. It is perfectly okay to have multiple givens. And so from here we keep going. Here we have segment AB is congruent to segment BC. Well, we know this is true because look at what our midpoint definition is. Our midpoint definition says that if B is the midpoint, which we stated, then segment AB is congruent to segment BC. So this is going to be the definition of midpoint. Which means if we correct our error here because we don't need the segment, then the value of AB should equal the value of BC. And in fact, we're trying to prove that the value of AB is equal to 9. So the value of AB is equal to the value of BC. That is the definition of congruent. Because we went from segment AB being congruent from segment BC to then saying that the value of AB is equal to BC. And so we went from the definition of midpoint to the definition of congruent. Now most of you at this point are like, that's a lot of pointless work. Well, yeah, it is if we're just trying to do the math. But if we're proving things, then we can say that these are true because we went from the definition of midpoint, we went from the definition of congruent, and so we've proved that what we're saying and what we're doing mathematically is in fact the correct process. So next we give you segment addition postulate, which if you remember is part plus part equals whole. Let me write out my parts here. Okay, so in this case I'm going to have segment AB plus segment BC is equal to the whole, which is segment AC. Now, the one thing that we haven't labeled in our picture yet is segment AB and segment BC. Well, we don't know what those are, so let's go ahead and put an X for both of them because we know that they're equal. We at least know that they're equal, so we know that they are the same, so we can put an X for both. Now, in our next step, we're going to plug stuff in. So what we can plug in is we can plug in the fact that the value of AB is X plus the value of BC is X, because we know that these right here, okay, this statement right here says that these are the same, so therefore they can both be X, which is equal to the total, or 18. And then from there we can say that this is just substitution property. And so now I have substitution property. This is just an algebra problem. I end up with 2x is equal to 18, which is combined like terms. And we finish the problem off by dividing by 2 and getting x is equal to 9. And our x was our segment, or the value of AB. So we now know that segment AB is equal to x, which is equal to 9. We can say all of that. Okay? Which means that our last step was the division property. And that is how you do the midpoint proof.